Morning, everyone. Wait a couple of seconds so everyone can join. Okay. So then let's get started. Welcome everyone to the third part of our webinar series on AI, building AI or building software products using AI. And the last piece of the puzzle will be that we actually build the application. So we have seen before in our previous sessions. Quickly change. In the first session, we saw Martin Kaiser developing a prototype, basically working with the customer, understanding the business, and live building something that the customer can touch and see how it would actually look like. So starting from this prototype, we then had the second webinar where Michael established the AI foundation for what we will be doing today. So he showed us how to build custom agents, how to build the AI infrastructure and framework that we will use today to actually build the application. If you have any questions, feel free. There is a little question box down there. Post something in there if something is unclear, and I will try to address this on the fly. Yeah. So quickly about me, I'm Florian Asmus. I'm the CTO at Prodyna. Been with the company for almost 19 years now. Always been doing software development, software engineering, system architecture. So always very technical, and also very excited about what's happening currently in the industry with AI really transforming how we work today. And we will get a glimpse of where this is going today. So what I will be showing you today is how to leverage what Michael did in the last session, building some AI primitives, custom agents, for example, to actually use them and build the product. Feed in the prototype that we built in the first session, and move it into rebuild it as an enterprise grade software. And this usually happens in these 4 steps. So number 1 is we have the prototype. So the prototype captures what we actually want to build, the business intent. Then from that, we derive specifications, pure business intent. So, okay, what do we actually want to develop? And we refine these specifications using AI to get a clear picture of what needs to be built. And in the next step, we will plan our implementation. So we will now feed in technical details of our technology stack we want to use for building the application, and architectural decisions and boundaries. And we will combine the business intent, the specifications, with all these technical constraints, and come up with an implementation plan, and break this plan into smaller pieces of work that we later on can delegate to our AI agents. And this will happen in step number 4. Step number 4, we will take this plan and actually build our system. Quickly going into a bit more detail. So phase 0, that was webinar number 2. That's the governance layer. So Michael showed that we used Copilot custom instructions, custom agents, hooks, skills to encode the way of how we do software development and make this knowledge accessible to the AI. So by default, if we just use the coding agent or the Copilot, it doesn't know about our context, our way of working, our constraints we have to fulfill, and by that, by setting this foundation, by explaining our concrete context to the AI, we now have the governance layer in place, which we can use and build on top. Then this is the first step we will see today. We will use the prototype, show the AI our prototype, show the AI the user stories that Martin documented during his prototyping workshop, and ask the AI to really condense the business intent behind that. So the prototype contains a lot of technical details. It's not structured from a coding perspective very well. It's a prototype. It's just rapidly built. But we can use the AI to get an idea of what we are actually trying to build and extract the functional specification from that. I'll have a look at the chat. Okay. So that's step number 1. Now we have the specification in place, and we can move on to the next step. So this is our phase 2, where we feed in all this technical stuff and use that to come up with a plan of how to build what the business requires, and break this down into smaller pieces of work, and also figure out which custom agent that we built last week. So little reminder for those who haven't attended, Michael built a custom agent for doing front-end development, for doing back-end development, for writing API specifications. And these agents are very focused and skilled in doing particular things. And we will use that in the planning phase now to identify, to map the little tasks we come up with to the specific agents, so that when we execute the tasks, they are not executed by a general AI agent, but they are actually executed by an expert. So that's what happens in this step. So we have our task list. We know which custom agent should execute this task, and this leads us to the last phase, where we then have a orchestration agent, so an agent that is capable of reading all the tasks that need to be done, order them so they are in a logical sequence, and delegate these tasks to the specific implementation agents, and basically holding the strings together and orchestrating all the sub agents, and make sure that they do the tasks in the correct order. So this will be step number 3, and I've drawn a little picture for you so it gets more clear. So we start with on the left side with the product finder prototype that we built. We feed this into the spec agent. The spec agent will produce a markdown file based on a predefined structure, what we want in such a specification, and it will extract the business intent. Then we have an agent that has shown to be very, very helpful, which is a review agent. That is, sole purpose is to go through the functional specification that we just created and checks it for consistency, for gaps, for logic errors, and asks questions, asks for clarification, suggests optimizations, and refines our specification. Yeah. So this is really helpful to get a second pair of eyes or a second pair of agent eyes onto the specification and get it more refined. Yeah. With this specification, we then hand this over to our planning agent, and as you will see in a bit, I've built the planning agent in a way that it creates GitHub issues. So it looks at the specification, it knows all the constraints, what technologies we want to use, and it will break down the tasks and create GitHub issues for all these tasks. So after the planning agent is done, we have a long list of GitHub issues that we need to implement to basically fulfill this business this specification. And last but not least, we then will tell our execution engine, our orchestration agent, hey, pick up all the issues for this specific feature and order it in the correct sequence and start implementing it by creating sub-agents that do the actual work, and they are experts in implementing these tasks. This also has the advantage of, number one, you could parallelize the work. So if you have independent tasks, it's not a problem to spawn all the agents in parallel to speed up the process. But also a very important aspect here is these specialized sub-agents, they have their own context. So they don't know like everything that needs to be done. They are only focused on a specific task with a very clear instruction, and their context window is very, very focused on the actual task. And this helps to steer the implementation much better than giving it a very broad overview of, oh, we need to do all of this stuff, and the agent will get lost much quicker in that case. So this is also a very important aspect here, having a focused context for each of the sub-agents. So that's the overall picture we are trying to address here. And I will now go into Visual Studio Code and actually show you how this works. So first of all, I've built the basic application already. So to have something that we can now iterate on. So as you can see, the application is already running. We can already see the list of products. So for those who didn't catch the first webinars, we have a fake company which is called Clip, and they have a lot, like 700, 800 different adhesive products, and they have different properties and different types of material and applications, and we want to build an expert application that allows us to quickly filter, search, and compare all of these products. So that's the general use case, and I've only implemented the landing page basically. So if you click on anything else like compare or detailed pages, they are not implemented yet. Yeah? So it's already a two-tier or three-tier application. So we have our front end, which is a single-page application. We have our back end with a REST API, which is written in Java, and we have a persistent layer, which in my case at the moment is a SQLite for local development, but it uses an OR mapper to actually in production use a Postgres database, for example. As a very standard tech stack, and if we go to our VS Code, you can see already the code that has been generated. So we have our Open API specification. This is already done by the process I will show you for one of the next features. So we have Open API specification. We have our backend implementation in Java, cleanly separated by domains, and it follows all the rules that Michael has defined in the specialized agents. To do a little recap here, we have special agents for developing backend. If we have a look at this agent, we see, this is a special agent for building Java backends with Spring Boot. And there is a clear tech stack that we require from that agent. We have a lot of architectural rules that need to be followed when implementing the backend, the application structure, and so on. So very detailed information. This is usually your developer guide. In this case, this is put into a markdown for the agent to always have in their head. So that's the advantage of having an AI agent. They always read they are perfect in reading and memorizing documentation. So basically every morning when the developer starts, they freshly read your entire developer documentation. So that's agent number one. Then we have a special front-end agent, and that also it's more or less structured the same, but with all the rules that apply to front-end development. And we also have a specialist for writing Open API specification for decoupling backend, front-end, and using like a common Open API specification here. Okay, so the first step that we now want to do is create the functional specification. And for that, I have defined my spec writing agent, and it exactly knows what to do. So it knows that it's not supposed to write any code or tests or anything. It's only meant for writing specifications. And it also knows where to read it from, because we have I told it where our prototype repository is. And if I now open a new session, I can pick our spec writer agent and tell it which specification it should write. So in the prototype, we have 5 user stories. And we will use them as an anchor point to get these specifications in. I already did that for 3 of them. So the first one is the overall application and layout. The second one is more sophisticated filtering. We have the product details page here. And I think the fourth one is the comparing. I will quickly get the specification file here. That's the one. And I tell it, hey, write spec for. Okay, so here we go. So now the agent checks the prototype repository, and it will load the content using GitHub MCP, so I don't have the prototype checked out or something. It's now really going via the tooling, the MCP server, contacting GitHub, checking, looking into the repository, and loading all the required information. This is a very common pattern. So often what we see at customers is that user stories, specifications, and so on is usually written in a different system. This approach, in our case, it is a prototype that we can directly link via GitHub MCP, but we could also point it to a Confluence or Jira for if depending on wherever the required information is. And as we need to tell the spec writer, hey, how do I discover the business the business intent, and then where can I find it? And from that, we can see it found the compare feature that Martin defined in the first session, and it will now start writing a specification. And we should soon see a functional specification 04 belonging to this compare feature. And this is really a common pattern that we see a lot. Maybe in the meantime, we can have a look at one of the specifications. So currently, Copilot is working. And let's see how such a specification looks like. So I instructed explicitly, hey, do not take any technical informations from the user stories, because with Figma Make you had a lot of like React specific, Tailwind specific information in the user story. So a mix of technical and functional specification. And I explicitly told it, do not take any technical assumptions and make it purely functional. And we can see we have the user story. We have what's in scope and what's out of scope in that case, which actors, some preconditions, and a lot of functional requirements, all with a nice ID. And the structure I have provided to the spec writer agent. So the spec writer agent knows how we at Prodina do specifications, and it will always work in the same way, and will be structured completely the same way. We have some, I think, some more UI specific information. We have some, I think, also some acceptance criteria down here. So the API, what the API needs to do, interaction flows, accessibility, and then some acceptance criteria down here. So we can even test against all this information. And here we go. So we now have a functional specification for our compare feature. So you see, it's built the same way as a user evaluating multiple adhesive products. I want to select up to 4 products across any page and compare them side by side. So basically a compare feature. And maybe I can, in parallel, run my review agent. So let's start a fresh session. Say, hey, review FS04. And it should pick up, I need to, the compare feature, I need to read the compare feature. And now let's see if everything is clean and logically there are no gaps or contradictions in there. And while we're doing that, I will open another session to get some planning done. So this one is running in the background, doing my refinement here. And now I will use the spec planner. I already did that for my feature number 2, and I will now do it for plan FS03. And this now should go into the details page and break down come up with an implementation plan. So what do we need to do? We need to maybe implement some new front-end components. We maybe need some new back-end endpoint to load all the details. And it will break all this down into GitHub issues. Let's have a look. Is the planning, the review is already in progress. Here we go. So we have some findings, some major findings here in the first iteration. And it always suggests like, the question is, I would suggest doing it this way. And because we don't have time, usually you now could go through all the findings and reiterate, maybe also talking to the business. What do you mean exactly? How do you like it? How should it be implemented? Yeah, and in that case, I will just tell it, please respond before I continue the next batch. Please fix the first findings and then show me the rest. Okay, so now it will go through, it will take the assumptions and rework and improve my specification to make it more clear. So this is now also working. Let's go back while this is in progress and see what our planning agent is doing. So it scanned the code base. It checked for existing GitHub issues because I can rerun the plan if I change the specification or I didn't do the full implementation yet. It will synchronize and check, okay, these are the issues that are still open in GitHub. Maybe I have some new ones. Maybe I have to update them because something in the specification changed. And now it will start iterating and going through a thought process. Okay, what is it that I need to do? Yeah, so this might take a second. The result will be, so okay, we can see there are no GitHub issues here. Now let's check for the current product entity and existing compare related code. So here we already see our first changes coming in. That's our review. So all 5 findings are fixed, and it now proceeds with some, still some major ones. Okay. Let's keep the first batch. So you can see the first step was okay-ish, but this reviewing and reiterating is really helpful to refine the specification before going into the implementation. That's all 10 findings. Let's fix them. Fix with your suggestion. Here we go. Let's see what the planning is doing. Aha. So the plan already came up with a lot of different tasks. Maybe we can have a quick look into the planner agent. Open preview. So here we go. So the planning agent I defined a couple of phases. So first you need to create the contract, then you need to create the backend components so the front end can use them, then review everything that you built for the backend, do the same for the front end, then do some integration testing and polishing, do some end-to-end testing, and update the documentation. So this is the general process of implementing, and it will now go through and define tasks and put them into the different phases. So you can see, first is I need to do some API work here. Then I need to do some implementation in the back end. We probably have some review task at the end. So once the implementation is done, let's review all of this. And you always can see we also reference what kind of agent we want to use for the task. And these are the agents that Michael built last week. And this is a quite long list of tasks. And at the end, it builds like a little dependency graph. So I first need to do that, then that, and so on. And now it will go and create GitHub issues for all of that. And we can have a look because I have GitHub here. So these were the tasks for FS02, also the function specification number 2. And you can see I have labels on here, which kind of agent should be used. It's labeled with the specification ID and the phase. And then we have the detailed description. Okay, what do you need to, what needs to be done? What are the acceptance criteria so we can test for that? What are the key files we will be modifying? And it even references, cross-references the tasks that need to be done. So all of this is captured in GitHub issues, and I think we should probably now have, yeah, here we go. So now you can see we have a lot of specification or implementation task for the third specification here. So let's go back. Let's see. It's still batch creating the issues here. It's all done via GitHub MCP. So very convenient. And let's go back. I think the review is also done. The specification is ready for implementing and planning. Here we go. So I will accept that. And this one is done. Oops. Yeah. So the review process is done for number 4. The planning for number 3 is in works. And I can now also, because I already did the task planning for our second specification, I will start a new session with a spec executor. So now I'm actually running, implementing the plan. I'll close everything here and say, hey, implement FS02. And this now should fetch all the GitHub issues that belong to this specification. So open issues labeled FS02. And now we should hopefully see, yeah, so it found a lot of issues. Now I'm seeing the front end foundation work needs to be completed first. So now evaluates in which order I need to execute. Give it a second. And while we're doing that, let's check back what our planning is doing. It's still now the review, integration, and testing documentation issues. So it creates more and more GitHub issues here, but it's almost done. Once these are completed or created, we get a little summary, and we can start the implementation for specification number 3. Yeah, here we go. So 21 issues have been created. These are the issues, the issue numbers, and in which order they will be implemented. Wonderful. Quality checks. Okay. There are some open questions here. Okay, let's. Okay. Please complete, plan complete 21 tasks across 8 phases, all synced to GitHub. Here we go. And here's the implementation. So what you will see now is I told the orchestration agent, hey, once you have loaded all the issues, start a sub-agent for each of the tasks. And this is exactly what happened here. So we see the different tasks all as now being spawned as sub-agents. And you can see first we have the Open API agent that does the API specification. We have a question about the model. This one should use a GPT for something. Yeah, exactly. So the sub-agents all define which models should be used. And in that case, I said, hey, use GPT 5.4. And even though the orchestration agent is using Opus, the sub-agents use whatever model I define. And this is really, really helpful because you can tailor the specific agent to or link it to a specific model that is very good for the specific task. For example, the GPT models 5.3 Codex or 5.4, they are very good at straightforward implementation and keeping a target and really working towards implementing a goal. So that they are really good at that. Opus, for example, especially Opus 4.6 is more creative. So for the specification writing, it's really, really good in that case. So I can select different models depending on the agent. There are more questions. How did I start? I actually used Copilot to create the agents. There are a lot of sources out there, like awesome Copilot, for example. But in this case, I really started using Copilot, describing, hey, I want a custom agent. This is what the agent should do. And I worked back and forth to create this agent. Yeah. Is there a chance to get access to the product finder repo or some AI dev starting repo? We don't really plan to release that. It's really purpose built for this webinar series. But as I said, there are tons of really good material out there. For example, as a starting point, Awesome Copilot is a very good collection. So just search for it, you will find it. Yeah. Okay, so here you can see it's still working on the first task. Maybe something a little hint for optimized token usage. At the moment, I only paid a single token for kicking off the orchestration agent that now spawns a lot of sub-agents. At the moment, the sub-agents don't cost anything. This will highly likely be changed in the near future. But at the moment, this is a very efficient way of token usage because you only pay 1 token or 3 tokens, depending on the model you use to call the orchestration agent. Yeah. So this is also something, token usage. When you use the chat, you go back and forth and iterate. Every single chat request you send will be a token or a premium request. Or if you use Opus, for example, it will be 3 premium requests for every single chat request. So if you use the chat, try to be more take more time to describe what you want to do instead of going a lot of back and forth with small iterations. Write a longer text, describe more precise what you want to do. That will save you a lot of tokens or premium requests. Yeah. Okay, so we can see what the sub agent is doing. At the moment, I kept it sequential, so it's not fully parallelizing everything, but in theory, you could have this this orchestration agent spawn the sub agents even in parallel. Yeah. So now it's working through. This can take quite a long time. So this can take hours, and hopefully at the end of the day, you have a running product. And maybe a little story about that. We did a hackathon yesterday in Cologne, and we gave the prototype to each team, telling them, okay, use this prototype, go through this process, build your custom agents, and implement your product. And all teams within 1 day really got a nice working version. They were free to choose their technology stack, everything, and the process really turned out to be quite robust, and the results were pretty comparable. Yeah. So that was really nice to see. You can engineer this process a lot further. So, and this is also something that Michael said last week. Currently, we have the whole AI operating system in our Git repository here. So in our .github folder, we have a lot of these all these AI specifications in there. What you want to do when you do this as a company, you probably will pull this out into a central repository where you can improve and iterate and encode your company's way of software development into your AI infrastructure and reuse this in all your repositories. You don't want to distribute this everywhere. There is a project which is called Agent Package Manager. It's an open source project from a Microsoft colleague, and this is exactly addressing this topic. You only have like a dependency file in your repository where you say, hey, I have my package JSON. In this case, I have my APM YAML, and then I can say, hey, this is a Java project. This is a whatever project. I need these agents. I need these custom instruction, these skills, whatever, and you just have to run APM install, and it will download a version, cleanly lifecycle versioned agent specification, custom instructions, whatever, and you can update them afterwards. So if there are new releases, you can always go into your project and update your AI infrastructure, and then you're really in a position to long-term engineer your AI workflows and your agentic SDLC. Yeah, because then you can really improve. You get feedback. This often the agent gets stuck here. Maybe we need some more clean rules and guidelines here. You can update this. Maybe you want to delegate the work into the cloud. In that case, you don't have a single working tree. You need more pull request based working, and you can then tailor all of this to your needs and iterate and improve over time. And then you really get an engineered agentic process for your software development. But the essential process of capturing the business intent in terms of specifications, deriving an implementation plan where your technology and all your technical decisions come in, and then implementing this with specialized agents. This is very robust and generally very well working process. And as you already can see, a lot of the stuff is being implemented into the different AI products. For example, there is a planning mode, a general planning mode in GitHub Copilot and Claude Code, for example. So this from spec to code might not be the best idea. Let's first plan the implementation. This usually gets better results. This has been a proven pattern, so vendors also put this into their product as a native feature. So there's a lot of stuff coming. It's a moving target for all of us. So for example, agent skills is something just new, and everyone is now adopting it. So it's nothing that is set in stone. It's still all work in progress, keeping up with what's happening out there. But this process itself is already quite stable I mean, Spec-it, for example, was one of the first toolkits for doing this spec-driven development approach, is more than half a year old, which is quite a long time in the space of AI software development. So the general process seems to be a good approach. The specifics and the features that you can implement are evolving and changing. So coming back to my slides. So this was my part. So actually the implementation is probably still running. So that's with AI. If you start bigger implementation tasks, that will keep you for a while. Sorry, I probably have to click here. So this is just too long for this 1 hour session here, but it will now go through all the tasks and implement them bit by bit. So thanks for tuning in. I hope you got a good impression of how to build an agentic software development lifecycle. If you haven't done so, feel free to check out the previous sessions to get the full picture from the AI generated prototype, where we basically replace sticky notes and wireframes with actually building a running prototype, to setting up the AI infrastructure, our AI operating system, to then putting the workflow on top and actually building the product, and feeding in all the business intent from the prototype, building on top of the AI primitives, and having a agentic workflow on top. Thank you very much. I hope you can take something with you, and feel free to reach out. And I wish you a good day. Maybe there is another question. Do still developers review the created stuff, or is it just reviewed by the review agents? Good question. I personally, it really depends on the maturity of your quality pipeline and tooling. Like, I would always recommend having deterministic code scanning tools, code security tools, in the pipeline to capture stuff that the non-deterministic AI just can't. But I think at the beginning you probably start with reviewing everything by developers, and if you get to a point where you trust more and more, I think then we will probably see code being just moved to the main branch once it passes all the quality criteria. But this really depends on a very solid development process, quality assurance, and yeah, then building trust, and probably not with your core systems. Maybe try it with more applications that are not that critical, and then move up the stack. Okay, that's it. I don't see any more questions. Then I will close the session and wish you a nice rest of the day.